Hey everyone, let's just jump right into this explainer and completely master Python loops from absolute scratch. We're going to cover the whole shebang today, from the very basics of syntax all the way to dodging those common beginner pitfalls. By the end, you'll have a rock-solid foundation for writing truly efficient code.
To kick things off, I want you to picture this. Imagine you're writing the software for a digital vending machine, and a user presses a button asking for 100 candies. Take a second and really think about it. How would you actually code that action?
Oof, yeah, look at that. That perfectly highlights the utter pain of repetition. Manually typing out print statements 100 times is just, well, it's a nightmare, right? It's slow, it's clunky, and honestly, it is exactly the headache that loops were invented to cure.
So here's our game plan for today. 1. The core tools. 2. Controlling loop flow. 3. Common loop mistakes. And 4. A quick loop recap.
All right, let's dive into section 1, the core tools, and start building our loop foundation.
Our very first tool is the while loop. Think of this guy as a gatekeeper. It's going to repeatedly execute a block of code, which, remember, in Python is grouped by indentation just as long as a specific condition stays true. But the very second that condition becomes false, boom, the gate closes and the loop stops dead in its tracks.
The step-by-step logic here is absolutely crucial for your code's survival. First, you check your condition. Second, you run the code. And third, this is the big one. You have to increment your variable. If you forget that third step, you'll accidentally create an infinite loop that just runs forever and totally crashes your computer. Nobody wants that.
Tracking this variable behind the scenes is actually pretty cool to see. You can notice how adding just 1 to our variable x during each single cycle eventually pushes it right past our threshold, which is exactly what triggers the whole operation to stop.
Now, while that first tool relies on a true or false condition, our next one, the for loop, is a completely different beast. It's specifically built to step through a set sequence of items, grabbing them one by one until it reaches the very end.
It's literally like a robotic arm pulling parts off a conveyor belt. Whether you're pulling names out of a list or printing every single letter in a super long string like Mississippi, Python handles all the heavy lifting for you without you ever needing to build a manual counter. But you might be wondering, what if you don't actually have a list of items? What if you just need a loop to run, say, exactly 50 times? Well, you just pair your for loop with the range function. You can tell it to start at 0, stop at 100, or even count by 5s if you want. It's incredibly flexible.
Moving right along to section 2, controlling loop flow. It's time to learn how to bend these loops to our will mid-execution.
Let's bring back that vending machine analogy for a second. We have a bit of a logical crisis here. What happens if a user demands 100 candies, but the machine only has 10 left in stock? How do we gracefully halt that transaction when the inventory runs totally dry?
The answer is the break statement. You literally just drop break into an if condition, and the moment you run out of candy, it instantly kicks you completely out of the loop. You can print a nice little out-of-stock message without crashing the program and without your machine aggressively dispensing thin air.
But what if we want to be a little more surgical about it? Let's say we're putting numbers 1 to 100, but we specifically want to skip over anything divisible by 3 or 5. We don't want to kill the whole operation, right? We just want to bypass a few specific items.
That is exactly what the continue keyword is for. It doesn't break the loop entirely. It just says, hey, ignore the rest of the code for this specific turn and skip straight ahead to the next number in the sequence. Think of it as your ultimate fast-forward button.
And finally, we have pass. Sometimes you're mapping out complex logic and you literally just need a blank space, like checking for an odd number, but wanting the code to do absolutely nothing in that specific scenario. Python hates blank if statements, so you use the pass keyword as a structural placeholder. It keeps the syntax perfectly happy while doing literally nothing.
All right, section 3, common loop mistakes. Because yes, even seasoned programmers mess this up sometimes, but fixing these will instantly make your scripts look so much more professional.
Mistake number 1 is basically like pulling the bottom blocks out of a Jenga tower while you're still building it, trying to remove items from a list while you are actively looping over it. It shifts the index and causes elements to get randomly skipped. The Pythonic fix? Just use a list comprehension to make a clean, brand new copy containing only the items you actually want to keep.
Mistake number 2 is using really messy workarounds just to keep track of where you are in a loop. Instead of doing that, think of Python's native enumerate function as a master key. It elegantly unlocks both the index number and the actual value at the exact same time, saving you from writing clunky code.
Mistake number 3 traps your entire program in a hamster wheel. It's the dreaded infinite loop, born from a while true statement with zero exit strategy. You should always establish a clear, logic-based exit condition right at the start, like checking if a user has typed Q to quit, for instance. And our last big mistake involves looping through dictionaries the hard way. Grabbing a key and then having to dig around for its matching value is just unnecessarily slow. Instead, using the items method unpacks them perfectly together. It's universally recognized as the absolute fastest, most Pythonic way to extract your data.
Which brings us to Section 4, our quick loop recap. Mastering these tools elevates you from a beginner to someone writing truly efficient software. So let's lock in these final takeaways.
So, we've seen how while loops handle flexible conditions, while for loops conquer predefined sequences. We learned that control statements like break, continue, and pass act as our steering wheel. And finally, embracing Pythonic syntax like enumerate saves us from those sneaky, hair-pulling bugs.
So, I'm going to leave you with this thought as we wrap up this explainer. You now have the exact fundamental logic required to bend machines to your will and banish repetition forever. So, with this awesome new power, what time-consuming task in your life are you going to automate next?